So good morning to everyone. So today we are going to learn another topic in Unit 1. So that is chromatography 1. In that chromatography, first we learn about history, who invented this, why this name is coined to this technique, and what are the developments. Okay. So first chromatography, it is a Greek word. From the chromatography word is coined from the Greek words. So particularly two Greek words. One is chroma. Chroma means color, and graphene means writing. Okay, so this technique was first employed by the Russian botanist, the Russian scientist, but basically he was a botanist, Michael Twist. So first he decided to separate the plant pigments, particularly chlorophyll, carotenoid, xanthophylls, through chalk piece. So first he prepared a extract of plant pigments, and then he transferred that extract on the surface of the chalk. So after some time, what happened, the constituents of that plant pigment, particularly chlorophyll, carotenes and xanthophylls, those have a characteristic color, that is green color of chlorophyll, carotenes orange color, and xanthophyll yellow color respectively. After some time, what happens, he observed the formation of different color bands, gaps, after some time. So that's what this technique is named as chromatography. Chroma means color and graphene means writing. And later this technique was developed by Leder and Kuhn, this liquid chromatography on keratins. And then in 1938 again they introduced the TLC, and then ion exchange chromatography. In 1915 reverse phase liquid chromatography. So here reverse phase means, here see, in chromatography technique, we have some basic component terminology. In the next slide we will discuss about the terminology. So first basic, now I tell you one thing about the components of the chromatography. So the chromatography involves mainly three components. One is stationary phase, mobile phase, and compound. And that stationary phase, if that stationary phase is polar in nature, then we say general phase of chromatography. If the stationary phase nature is non-polar, then we use this reverse phase term. And next, in 1954, Martin and Singe, they won the Nobel Prize. Actually, they invented this one, reverse phase liquid chromatography. And then in 1959, the gel fermentation, that is one more technique, introduced in 1965. And that was also responsible for the development of liquid chromatography. In 1944, from the Martin laboratory, the separation of amino acid by the paper chromatography, that was reported. Okay, and then in 1952, the importance of the chromatography was observed when the both Singe and Martin were awarded for a Nobel Prize. So again here see, here we mentioned the names of those scientists, and actually for their contribution, toward the chromatography, they awarded Nobel Prize. In 1959, the technique known as gel filtration chromatography was observed, which is used to separate low molecular weight substances from high molecular weight of substances. And then in 1960, the further improvement in liquid chromatography led to the development of HPLC. So it is a, we can say, a breakthrough in the field of pharmaceutical, in almost pharmaceuticals and food technology. What else? Every field, this HPLC made a drastic change. The invention of this one changed the perception of scientists. And then in 1970s, one more improvement in the field of adsorption chromatography in the form of affinity chromatography, so which is mainly based on the biological interactions. Okay, so this is about the history of chromatography. Let's see the definition of the chromatography. So what is, how we define the chromatography? So chromatography is a separation technique. So particularly we can say the physical method. It is a physical method, and through which and it is a separation technique based on the different interaction of a compound with the two phases. So here what we say, we take the different constituents of a compound, and that compound is introduced between two phases. Then what happened, this compound may show the different affinities towards these two phases. So that affinities here he mentioned as interactions between two phases. So thereby what happens, the compound travels through the supporting medium. Here the supporting medium is stationary phase. Okay, and then working model, it is a physical method by which substances are separated from its mixture by redistributing themselves between two phases. So here see, so this is extension for the first paragraph. So here what happens when we introduce a mixture of compound on the surface in between these two phases, then what happened? The components of that compound were redistributed themselves between two phases through adsorption, or we can say partition, or ion exclusion, or ion exchange. By this method what happens, these components of a compound or sample solution that will be redistributed themselves between two phases into different extents. Okay, so this chromatography basically consists of a, here see, this is the important parts of the chromatography. So chromatography basically consists of a stationary phase, which is immobilized, and a mobile phase. So stationary phase is immobilized. Immobilized means that will be placed on a support, particularly that made of with support particles, or on the inner walls of a column, or we can say we can apply the supporting particles on the slide also. So that is known as thin layer chromatography. So stationary phase may be stationary phase may be exist as solid or liquid state. So that means the physical state of stationary phase. So physical state of stationary phase may be solid or liquid. Okay, and then mobile phase. So it is mobilizable. So mobile phase, the name implies that it is movable. It is movable. Whereas stationary phase is immobilized, so that cannot be moved. Okay, next, mobile phase. So moving in a definite direction. Definite direction means, see, generally we introduce this mobile phase on the surface of the stationary phase, and then we allow to travel in upward direction or downward direction. So that depends, that basing on the technique, which technique we adapt. Okay, so here see, the definite direction. So it may be travel from bottom to top, or top to bottom, or we can say two-dimensional or radial. So these are the different directions. So those depends on the technique which we adapted or we inculcated. Okay, next, here see, the mobile phase may be a liquid or maybe gas. So as like stationary phase, that is stationary phase may be a solid substance or liquid substance. Like that, mobile phase may be a liquid or gas. The mobile phase moves through the chromatography column. So that is actually we say that one as a stationary phase. So that means this mobile phase moves through the stationary phase, where the sample interacts with the stationary phase and it is separated. So the components, the compound which is redistribute themselves between the mobile phase and stationary phase. So okay, first the compound will be introduced on the stationary phase. Later, then what we do, we introduce the mobile phase. At that time what happened, the redistribution of this thing may happens. Redistribution of that compound takes places between two phases through that may be adsorption. If our stationary phase is solid, then we can expect the adsorption technique or principle or method. And if our mobile phase and liquid phase are liquid gases, then partition may take places. Or if our mobile phase is solid, that means a ion containing solid, so then ion exchange may take places, ion exclusion or ion exchange. So when these two things may happen when our stationary phase is solid. Next, here see, the one more important factor is retention time. So retention time means the time spent by the component of a compounds on stationary phase or mobile phase. So that gives the retention time. So here see, the time taken for a particular analyte. So here we are saying analyte component as a analyte. Okay, so analyte to pass through the system from the column inlet to the detector under the set of condition. So here see, in column chromatography or in advanced chromatography HPLC, then what we do, we allow the analyte to pass through the or redistribute themselves between two phases, that is stationary phase and mobile phase. So at that time what happens, this analyte may show the different affinities towards the different phases. Some analytes may show more affinity toward the stationary phase. So the analyte which shows the more affinity toward the stationary phase, that will spend more time on the stationary phase, so its retention time is more. And the analyte which shows the less affinity toward the stationary phase, so obviously that will show the more affinity towards the mobile phase. So hence that analyte will be separated out. So that means the analyte which shows the less affinity toward the stationary phase, that spends less time, so that means we can say the retention time of that analyte is less. And next, see the illustration. So how the chromatography works. So this is, see, at the bottom we shown the mobile phase, and this is stationary phase, and this is the component analyte, mixture of analytes, or we can say sample. Okay, sample, you can say sample or mixture of analytes. Here see shown three different colors: yellow color, blue color, and red color. So and the sizes also are shown in a different way. So here see what happens. The blue color here, after applying the mobile phase during the separation, here this one before separation, this is after separation. What happens? The redistribution of these analytes taken place between the stationary phase as well as this is the mobile phase. So here the mobile phase is moving from top to bottom. So due to capillary action, here the responsible force of moving mobile phase from top to bottom is capillary force. Here see, while moving this mobile phase, what happens? It is taken up these, here see, four components: black, blue, red, and yellow. Okay, here see. So while moving this mobile phase from top to bottom, it is taken along with blue color, yellow colored, faster, somewhat what we say, somewhat less speed than yellow color. So this is red color, and this is black color, and this is blue color. So it indicates that these components, the analytes, has shown different affinities towards the different phases to different extent. So that means this blue color has more affinity towards the stationary phase, so that's why it remains at the bottom. And the black color dots shown the somewhat less affinity compared to blue one toward the stationary phase, and they shown the less affinity toward the mobile phase, that's why they travel this distance. And these are shown the somewhat more affinity toward the mobile phase comparatively these two, so that's why it travels more distance. And this yellow colored analyte shown the more affinity toward the mobile phase and less affinity toward the stationary phase, that's what it travels more distance. Okay, so this is known as the redistribution of analytes or components themselves between two phases. So this is the principle which involves during this technique. Okay, redistribution of analytes or components to between two phases to different extent. So this is the X factor. By means of this only we can separate the analyte from its mixture. Okay, next, principle of chromatography. So just now I told you this is a physical method of separation that distributes the component. Again, so repetition of this one. Okay, this is illustration, and whatever we discussed at previous slide, so that is mentioned here. The physical method of separation that distributes the components of to separate between two phases moves in different directions, in definite directions, and substances are separated based on their differential distribution between two phases. So differential distribution or redistribution or partition or adsorption, whatever you say, so this is a different interaction or different affinities, whatever it may be. So due to the differential distribution or affinities or interaction between the two phases, so we can able to separate these components. And substance will move with the mobile phase at a different rate, depends upon their partition or distribution coefficients. Okay, next, the factor influencing the separation, the factor. So which factors influence the separation? So this is the separation. So which factors? The intermolecular interactions between the two phases. That means this blue color component has more affinity toward the interaction or more affinity toward the stationary phase, so that's why it remains at the bottom. And this has less affinity toward the stationary phase and more affinity toward the mobile phase, so that's why it travels more distance compared to the remaining. So that is intermolecular interaction. And extension of dispersion of solute molecules over the stationary phase. So dispersion, so it has less dispersion, it has more dispersion. So dispersion means distribution. And the analyte interaction more strongly with the stationary phase will take a longer time to pass through the system. So that means this one. So this blue color has shown the more affinity toward the stationary phase, so it will take more time to separate, or more time to coming out from the stationary phase. And these interactions are usually chemical in nature, but in some cases physical interaction. So particularly if you consider the adsorption, I think you have studied in first year. The adsorption is two types. One is physical adsorption, second one is chemical adsorption. So in that physical absorption, the responsible force is van der Waals intermolecular forces, and whereas in chemical, so a unstable or a weak bond forms between the adsorbate and adsorbent. Here the adsorbate is our stationary phase, and adsorbent is our analyte. Hence former analyte will be collected last and later analyte will be collected first. So that means here see the analyte which has the strong affinity toward the stationary phase, so it will be collected last, and the analyte which has the more affinity towards the mobile phase and less affinity towards the stationary phase, that will be collected first. Okay, next come to the classification of chromatography. So we can classify the chromatography and based on mechanism, or you can say principle, and based on phases, physical state of phases, based on the shape of the chromatographic bed. Bed means stationary phase. Okay, so particularly first two are very important, and based on the mechanism, that means principle. Here adsorption chromatography. So adsorption chromatography, we can expect this adsorption chromatography where the stationary phase is solid. Okay, and the partition chromatography, when our stationary phase is liquid and mobile phase are liquid or gas, whatever it may be. Okay, and next based on the phases, if a solid phase chromatography means the stationary phase is solid liquid chromatography. So that means here liquid is mobile phase, solid is stationary phase. Here solid gas chromatography, again solid is stationary phase, gas is liquid mobile phase. And liquid phase chromatography, liquid, so that means both are stationary phase as well as mobile phase, both are liquid in state. And liquid gas chromatography, here stationary phase is liquid and mobile phase is gas. So based on the shape, so planar chromatography, that means here we use planar things, particularly with respect to the stationary phase, a paper chromatography. Here under paper chromatography, that paper acts as a stationary phase when that is soaked in water. In thin layer chromatography, what we do here, we apply the slurry of what we say amorphous finely divided or finely powdered supporting medium. So that will be made into the slurry, and then we apply that slurry on TLC plate, and then we heat that TLC plate. So thereby we can get a thin layer chromatography, that means a stationary phase. And column chromatography, in that column chromatography is that here the stationary phase is packed in a column. Column means nothing but a burette, just like a vertical cylinder or vertical glass tube, just like a, it seems like a big burette. Okay, and next one is flowchart diagram of chromatography. So again it is classification chromatography, so where we can see the adsorption. So when the competition between the solid and gas and liquid, so here the solid is our stationary phase. When our stationary phase is solid, then here the mechanism or principle involved in that chromatography is adsorption. And if the competition between the liquid, when our stationary phase is liquid, then we can expect partition principle or partition chromatography. So if it is our mobile phase is gas, then we can say gas solid chromatography. If our mobile phase is liquid, then we say we have an example, that is column chromatography and thin layer chromatography. And in the, again come to the partition chromatography, here our mobile phase, stationary phase is liquid and mobile phase is gas, then it is GLC. And again if our liquid phase, mobile phase is liquid and stationary phase is also liquid, then we can say liquid chromatography. For that again paper chromatography, and so the column chromatography may not comes under this, then maybe it is better, it is paper chromatography. Examples for partition chromatography, paper chromatography, HPLC, gas liquid chromatography, and examples for adsorption chromatography are column, thin layer, and solid gas solid chromatography. And see, the, just now we saw the mechanism or principle. So adsorption chromatography. In adsorption chromatography, the principle involved is the absorption of analyte on the surface of stationary phase. So that means our stationary phase is a solid, and see, this is our stationary phase. This is our stationary phase. These are the analyte particles. So these analyte particles are adsorbed at the surface of the adsorbent. So that's why this the concentrating of analyte at the surface of the adsorbent is known as adsorption. And see, this adsorption chromatography, during adsorption chromatography, so this is the stationary phase. What happens on the surface of the stationary phase? These solute particles, that means analyte particles, are deposited or adsorbed, and these are strongly these particles has somewhat, we can say, good affinity or strong affinity toward the stationary phase. So that's why those are attached at the surface, and these are has less affinity, so that they are not adsorbed. Okay, see, adsorption chromatography is probably one of the oldest type of chromatography. So around means so it is the oldest chromatography. It utilizes a mobile phase which may be liquid or gas phase, that is adsorbed onto the surface of the stationary phase. So here what happens, whatever mobile phase we introduce, first of all what happens, it may adsorbs on the surface of the adsorbent. Adsorbent means our stationary phase, and then what happens, and a dynamic equilibrium establishes between the solute in liquid phase and solute towards stationary phase. So the equilibrium between the mobile and stationary phase accounts for the separation of different solutes. So the equilibrium, so here the equilibrium should establish between the phase, mobile phase and the stationary phase, so of different solutes. So that means here, see, equilibrium of the mobile and stationary phase accounts for the separation of different solutes. So that means here, see, if equilibrium is established soon, that means separation may take place fast. If we establish equilibrium is to establish equilibrium between the mobile and stationary phase, if it requires more time, that means the rate of adsorption separation is slow. And see the principle. So just now I told you the principle of adsorption chromatography involves the competition of components of a sample mixture. So here components means we can say analytes. So competition arises between whom? Two phases with respect to analytes or components of a mixture for active site and adsorbent. These active sites are formed in molecules due to. So here, see, you can say you can see this one. So this is the surface of the adsorbent. At the surface of the adsorbent we may have some active sites. So the competition arises to occupy the active sites by whom? These analytes are components. Okay, so those active sites are created due to the cracks and edges. The separation occurs because of the fact that an equilibrium is established between the molecules adsorbed on stationary phase and those which are flowing freely in the mobile phase. See, here, see, an equilibrium established between the molecules which are adsorbed on the stationary phase, and these are the free molecules which are dissolved or adsorbed, which are here, see, which are freely flowing in mobile phase. These are freely flowing in mobile phase, and now what happened, the equilibrium established between these adsorbed components are freely flowing components between two phases. So that decides the rate of separation. And the more affinity of the molecules for a particular component, less will be the movement. So that means the particle, the analyte which shown the more affinity toward the adsorbent, so obviously that will have what? That will have less movement. Okay. So this is the principle in that, and the types of adsorption chromatography, column chromatography, thin layer, and gas liquid chromatography. We can find adsorption chromatography. And next, see, partition coefficient. So it is very important one, and here, see, in this chromatography or adsorption chromatography, in later classes we may come across RF value. So that RF value is a retardation factor, so that retardation factor we may discuss in this thin layer chromatography as well as paper chromatography also. Okay, later we will discuss that one. And next, partition chromatography. So definition, this form of a chromatography based on the a thin film formed on the surface of the solid support by a liquid stationary phase. So particularly this partition chromatography. In that partition chromatography, the actual physical state of our stationary phase is liquid. So actually that liquid is uh, held by or embedded on the surface of the thin film, like paper chromatography. If you take the example, if you see the example of paper chromatography, the paper is not a it doesn't we can't say it is a stationary phase or mobile phase, but it is acts as a supporting medium for the stationary phase. In paper chromatography, the stationary phase is water. So what we do when we for example, if you drop 1 or 2 drops of water on the paper, what happens, that may not be percolated, so it may be absorbed by whom? Paper. Why? Because the paper is made of with cellulose. So cellulose has number of polyhydroxy groups. So water also has water is an ionic compound. So between these two, what happens? The OH groups of cellulose, that means paper, and OH of water. So in between, hydrogen bond formation takes place. Due to the hydrogen bond, due to that hydrogen bond, it is a one type of intermolecular attractions. Due to that intermolecular attractions, our paper holds the water molecule. So thereby, our paper acts as a supporting medium for whom? Stationary phase. Here stationary phase is what? Water. So here the water forms a thin layer on the surface of the paper. That means solid support. So that solid, that liquid is acts as a stationary phase. Now the solute equilibrates between the mobile phase and stationary phase. So again same thing, an equilibrium, equilibrate means the distribution takes places between the stationary phase. So here you can see this one, this stationary phase, and this is mobile phase, and the red colored has more the red color dots show are has the are held by firmly held by the water molecule, and whereas these green color dots are freely moving, means these are this may have different or opposite nature with respect to the water. So water is a polar, so it holds the polar analyte, and it leave left behind non-polar analytes. So these non-polar analytes are freely moving with the mobile phase. So that's why this green color will be separated first. After some time, the red color will be separated. So this is known as partition distribution. So partition. Okay, separation is based on the solute partitioning between the two phases. So relative solubility. So if this green color is more soluble in mobile phase, so that is more partition shows the partition what we say dissolution. So more partitioned into the mobile phase. The next principle, separation of components of a sample mixture occurs because of a partition. So just now we discussed what is partition. Here this red color has more affinity, shown the more affinity towards the water, so that's why these are held, and these are shown less affinity towards the our stationary phase, and these are partitioned into the mobile phase. Okay, so here they occur because of partition. The stationary phase is coated with a liquid, so which is immiscible in mobile phase, and the partition of a component of sample between the sample and the liquid gases and stationary phase retarded some components of samples more as compared to others, and this gives the basic separation. So that means here see the partition of components of a sample between the liquid gas and stationary phase retards some components of a sample of more as compared to other. Okay, so this red color has the retardness. These are not ready to go with mobile phase. And next, the stationary phase immobilizes the liquid surface layer, which becomes stationary phase. Mobile phase passes over the coated adsorbent, and depending upon the relative solubility in the coated liquid, this operation occurs. So the components of sample mixture appears separated because of difference in their partition coefficient. So partition coefficient value is Kd. So Kd means we can say, already we have studied in previous class, that is solvent extraction. So the partition coefficient or distribution coefficient, this distribution is governed by Nernst-Law. According to Nernst-Law, Kd is equal the concentration of analyte in stationary phase by the concentration of analyte in mobile phase. So that gives the partition coefficient value. Okay. So these are the types of partition coefficient, partition chromatography. So liquid chromatography, example TLC, gas liquid chromatography. Okay, so this is about basic information about the chromatography. So what are the history and the principle, classification and the components of a chromatography. Okay, so I hope you have understood this. Okay. And next in tomorrow next class we will discuss about one by one. So first we discuss about thin layer chromatography, then paper chromatography, column chromatography, HPLC, GLC, ion exchange chromatography, etc., etc. Okay, so